Namaste and welcome back to the DSA classes. Today, my dear friends, we are going to be solving a question called as allocate books, which has been previously asked in companies such as Google. Again, a very famously asked question, and the very reason that I am picking this question to solve is because this question, when you look at it, you will not realize that this is a question which can be solved using the binary search algorithm. But if you use binary search, this becomes very easy to solve. So I will be solving a couple of such questions which is going to help you identify how to use this binary search algorithm in situations where you wouldn't really think of using it, right? Now watch it and understand the question first. So the question says that they are going to give you a book, an array of books like this. Let us assume this array is called as A. Now in this array A, what they have given is these values 12, 34, 67, 90. Now what this means is that there are totally 4 books. First book has 12 pages, second book 34 pages, similarly 67 pages and 90 pages. I hope you're able to think. So they have given you the number of pages in each book as an array. Now they will also give you another value called as B. Now inside this B, you are going to have any number, for example 2. Now what this means is that there are 2 students. You must allocate this book to these 2 students. That is what the question is asking you to do. But the question has also set few conditions upon you based on which only you must allocate books to these students. What are those conditions? These are those conditions. First condition, a book will be allocated to exactly 1 student, which means if you take this first book, you cannot tear the book into 2 halves and give 6 pages to this student, 6 pages to this student. Such a thing is not possible. Entire book you have to allocate it to 1 student. Okay. Each student has to be allocated at least 1 book, which means if there are 2 students, you can't allocate all books to one person and leave the other person empty. Such a thing is not possible. Allotment should be in contiguous order. Contiguous order means how I should allocate it, so I should first allocate the first book, then I should allocate the second book, then I should allocate the third book, then I should allocate the fourth book. So it should happen one after the other in a contiguous manner. I hope you're able to think. Next, all books must be allocated, which means what it is saying is that ultimately you can't leave even a single book unallocated. You must make sure all books are allocated to the given number of students. No book should be left out. I hope you're able to think. Now, keeping these conditions at the back of our mind, how would you go about doing this allocation? Let's think about it. Okay. Now, basically I will take the first book, okay, allocate it to the first student. So here, now they have 12 pages with them. Next, 34 pages book also I'll allocate to the next student, first student itself. 67 pages also I'll allocate to the first student only. Now there's only 1 book remaining. And the condition says that at least 1 book every student should have. So I can't leave this person empty. So this 90-page book I'll allocate it to him. I hope you're able to think. Any confusion till here? So I've allocated to both the students, right? One more way of allocating is first book to the first student, second book to the first student, then the other 2 books to the second student. This way also you can allocate. Or you can allocate only the first book to the first student and the remaining 3 books to the second student. This way also you can allocate. Now if you look at it carefully, you will notice one thing, that if in case I count the total number of pages which has been allocated to the students, you will observe one thing, that the first student in the first permutation or combination, I have basically, if I add them up, 12 plus 34 plus 67, 113 pages worth of books I have given to the first student. Second student has got 90 pages. So, do you see one person has higher number of pages than the other person? It is always going to be that way. This person has higher number of pages. How are you able to think? Next, if you notice, this if I add 12 plus 34, 46 pages, 67 plus 90, 157 pages. This time, the second student has more pages than the first student. But somebody has maximum number of pages, right? It's not always evenly distributed. Here 12 pages, here if I add all of them, 191 pages. So again you can see maximum. So what the question is asking you to do is, they are telling that see always one of the students will end up getting a maximum value, maximum number of pages. I am just marking the maximum pages. See maximum, maximum, maximum. Now if you look at these maximum values, one of these combinations, the maximum value is the minimum. What do you mean, sir? You may ask. 191, 157, 113. All of them are max. In that which is minimum? 113. So they want you to allocate books in such a way that the student who has the maximum number of pages, that is as less as possible. Because maximum pages can be 191 also, maximum pages can be 157 also, maximum pages can be 113 also. They want you to minimize the maximum. And if you minimize the maximum, you can notice that 113 is what you will get if you sequentially allocate books using these conditions. Now, whenever sequential allocation comes into the picture, whenever you have to allocate something sequentially, many a times, 9 out of 10 times, this can be solved by using the binary searches algorithm. Oh really? How, you may ask? Let me show you. But before that, I'll just take another example. See, if you look at this, you may think, oh, I'm using binary search because it is sorted. This array of books need not be sorted, my friends. For example, this is another example where you can clearly see that it's not sorted. The array is not sorted. B value is 4. So I have 4 students. Now amongst 4 students, based on those 4 conditions, if I allocate, every student must have at least 1 book and I should allocate it in a contiguous manner, which means if I allocate 5, then there are 3 more students. So 17 has to be allocated to the next student, 100 has to be allocated to the next student, 11 has to be allocated to the next student. So each person gets 1 book. In that, 1 person got the maximum number of pages. That is only the minimum because no one else has got any other max. That is only the minimum. I hope you are able to think. So 100 should be the output. So I hope you are able to think. Such inputs also can be given to you. Now that you understood the question, let's think of a solution. Okay. So before that, I want you to pause this video and try to come up with a brute force approach. It need not be the most optimized approach, just a brute force approach. How would you go about solving it, right? Can you recursively solve it? Can you solve it using iterations or loops? Think about it, how you would be solving it. Okay. Assuming you tried something on your own, now let me take you to the optimal solution. How would you think of solving this optimally? Listen to. Now guys, I want you to focus. So this is the array given to me and let us assume that the B value is 1. The B value is 1. Now I want you to think of it. There is only a single student. There is only a single student. If there is a single student, then would you agree that you will have to allocate all the books to him? Which means the maximum number of pages this person only will have. There is only one person. And what will be the maximum number of pages if in case there is only a single person? It will be the sum of all the pages of all the books, which means 12 plus 34 plus 67 plus 90 is nothing but 203. Which means, would you agree, I'm just keeping 203 here, 203 is the maximum number of pages that can be allocated to a student. Would you agree with me? Okay. Now, let us assume instead of 2 or instead of 1, you have totally maybe 3 students. I'm just giving a value 3. Okay. Now, if you have 3 students like this, maybe what you may do is, you may take which is the minimum value here? Look at the minimum value here, 12. Now this 12 may come here, may come here, may come here, may come. The position of 12 doesn't matter. One of the students, you may allocate only that book which has 12. Possible. There are 3 students. To one of these students, you may allocate this book which has just 12, and because it has to be sequential allocation, in this case only the first person will get 12. But point is that if I ask you what is the maximum number of pages somebody can get, you would told 203 if there was only one student. Similarly, if I ask you what is the minimum number of pages that a student can get, it is nothing but the book with the least number of pages or minimum pages in this array, which in this case happens to be 12. So can I tell 12 is the minimum number of pages which may be allocated. 203 is the maximum number of pages which can be allocated. Now, why 12 is the minimum? Because you know that at least one book should be allocated to every person. So, maybe to one person I will just allocate this book with 12 and nothing else. So, minimum number of pages is 12, maximum number is 203. Now, would you agree? Allocation of books or the total number of pages which may be allocated to a person will fall within the range of 12 to 203. Common sense it is that the range will be between 12 to 203. Now ultimately what we are trying to do is, we are trying to find a value between 12 to 203 which is such a value that is the maximum number of pages that I can allocate to one of them, such that compared to the different combinations of allotment, that maximum value is the minimum. That maximum value is the minimum. Did you understand? So that value will lie between 12 to 203. Now, this array may be sorted, may not be sorted. But the range of values from the minimum number of pages to the maximum number of pages is 100% sorted, is 100% going to be in the ascending order. Now, if you are going to search for a value in a sorted sequence, what will you use? Binary search. So, are you able to see how binary search may be allocated here? Because ultimately I am searching for that value, searching in a sequence of values which is ascending, which is sorted. So, I can use binary search. The most efficient way to search is by finding a mid and that way cutting, dividing the size of my input, right? So, how are we going to do it? Simple. Listen to me. What I am going to do, guys, is I am going to develop a simple algorithm, and here let us assume the total number of students is not 3 but is 2. I am changing it to 2. Here I will just remove all these students. From scratch we will start. Now watch it. What I will do is, I am going to create a variable called as students, guys. Initially I am going to initialize it as 1. I am going to initialize it as 1. Why? You will soon understand. Also, to keep track of per student, for a student, how much is the total pages which is being allocated, I am going to create another variable called as student page count or SPC. And initially I will make it as 0 because initially no book has been allocated to the student, so the pages is 0. I hope you are able to think. Now, listen to me carefully. What I will do is like this, okay. So, low, I will set it as the least amount of pages. High, I will set it as the most amount of pages or the max pages you can allocate. Now, what I will do is, I will find the mid, low plus high divided by 2. 12 plus 203 divided by 2 is nothing but 107. That is my mid value. Now, how I am developing an algorithm is, I will assume that the value I am looking for, that is the minimum out of that maximum allotment, that value that I am looking for is this mid value. I may be right, I may be wrong, but I am assuming. How will I know whether my assumption is correct or wrong? For that, I have to check whether this 107 is a possible solution or not. I should check, isn't it? How will you check, sir? Very easy. Watch it. What I will do is, I am going to run a loop on this array A. So, I will start I from the 0th index. So, see, and this I will go to the last index. So, I will run a loop for I from 0 till length of A. Now, inside that, what I will do is very simple. I will start allocating books to the first student. So, I am just bringing the first student. But before allocating a book, I will always check whether the total number of pages that the student has, is it lesser than this value? Because I don't want the maximum number of pages to be more than this value. I don't want it to be more than this value. So, I will check if in case it is lesser than this value. So, how will you check, sir? Very simple. Right now, the student's page count is 0. Before allocating a book, that is this ith book which has 12 pages, I will put a condition. If in case I take the student page count, to that if I add the ith element, will it be less than or equal to this value? I will check. Right now it is 0. 0 plus 12 is 12. Is 12 less than or equal to 107? Yes, which means I can allocate this book. That is the meaning, right? So, to allocate it inside the if condition, what I will do is, I will take SPC and update it by saying, please take the old value of the student page count and to that add the ith element. So, 0 plus 12 is 12, which means student page count becomes 12, and hence what I have done is I have taken this 12 and I have allocated. That is what I am showing. Hope you are able to think. Now, allocation must happen contiguously. That was one of the conditions. So, I will continue and I will see, can I allocate more pages to him? I will keep allocating pages to him till it doesn't cross this number. I will keep allocating. So, what I will do is, next I will see, 34 is the value. Now, I will see if at all I had allocated 34 to him, then his existing page count plus this new books page count, if I add them together, will it be greater than m? That is what this condition is doing. So, what is the existing value? 12. 12 plus 34, I will check, which is nothing but 46. Is 46 less than equal to 107? Yes, which means this book also I can allocate. So, I will allocate it to him, and that updation I will make it in the student page count. So, totally he has 46. Hope you are able to think. Any confusion? Next, I am within a loop. I moves forward. Now, I am checking whether this next 67 can be allocated. I am checking. Before allocating it, I will check. To the existing page count, if I added 67, will it become more than this m? You know, if I 46 plus 67 I had, 113 is what I will get. 113 is what I will get. Is 113 more than m? Yes, it is more than m. Which means max I wanted to allocate 107. But if I allocate this book, I am allocating more than the max I want to allocate. I will not do that. So, I can only allocate these two books to him, which means I will come to else. Else means what? I can't allocate the next book. But you have to allocate all the books. That is what they are saying. Totally there are 2 students for you. So what I will do is, I will now tell, okay, I can't allocate to this student. I need one more student. So I will increment the value of student plus. So student will become 2. This is the second student. Now, I did student plus, but what is the question saying? That I can have maximum 2 students. Now, before bringing in one more student, I must always check whether the student count is cross this or is it equal to this. This is very important because only maximum 2 students I can have. So, how will I check? I will check if in case that student's value, is it greater than the B value? If it is greater than the B value, then there is a mistake because maximum 2 students I am going over and above that. So, if it was greater than B, I will just return false, telling, hey, this cannot be a solution, But in this case, student's value is 2, B value is 2, which means it's not greater, which means still I am correct. So, what I will do is, now I want to tell that, hey, listen, first student is over. Now, second student, I want to allocate 67. Which means his page count is going to begin from 67 because first book only 67 is there. But look at this student page count 46. 46 was the page count of the previous student. Now it is new student. His value starts from 67. So what are you going to do if you ask me? What I am going to do is whatever is the ith value. So whatever is the ith value, I am going to assign it to SPC. SPC was 46, now I will assign 67, so it will become 67 and 67 is the page count of the new student. Hope you are able to think. You are within a loop. Again check, if in case I moves forward, check if the ith book, if I allocate it to this student, will it be lesser than this or equal to this? So, if I do 67 plus 90, it will be 157 and 157 is greater than this 107, which means I cannot be allocating it to him. So, if I can't allocate it to him because it is greater than this m value, what should I do? I need another student. So, student plus students becomes 3. But tell me, can I have a third student? No, because maximum is 2 students. So, obviously, this value cannot be the right value. Did you understand? Because if it was the right value, I should have been able to allocate all the books to all the students, but I have not been able to allocate all the books. There cannot be a third student because B is 2. That is what this condition will check. If in case student's value becomes greater than the number of students allowed. 3 is greater than 2, which means I will return false. False means not possible. This is not that maximum value. Oh, if this is not that maximum value. Now, why is this not the maximum value? Because 107 was not enough allocation to one student such that all the books could have been allocated to 2 given students. It was not. So what to do? What to do means, if at all I want to find a value where more books can be allocated to the first student, then this m value, should it come this side or should it come this side? Should it become lesser or should it become greater? Anyone with eyes will tell me, sir, m value has to increase. If m value has to increase, next time in a binary search, if m has to come right side, should I adjust high or should I adjust low? Anyone with eyes will tell me, please adjust low. And that is what I will do. I will make low as mid plus 1. I will make low as mid plus 1. Now, I am just moving the range of values a little bit for you. Okay. Now, very simple. Watch it. This time, again, low is 108 plus 203 divided by 2 is nothing but 155. So, that is my new mid value. 155. So, I am moving everything this side so that you can just understand this. So, now my new low is 108. My high was 203 only and my mid becomes 155. Any confusion? Now I am assuming that 155 is my answer. That is the maximum number of pages that I will be allocating. Now to check whether it is right or wrong, what I will do is I want to check whether this is a possible solution. How to check whether this is a possible solution? Same logic. So see, again I will be using this. So I will reinitialize everything. Students will be initially 1. Student page count will be 0, right? And now when I start, I value starts from the beginning. Now I will check if I can allocate 12 to the first student. Now to check that, first what I will do is I will take 12, add it to the existing student page count. So 0 plus 12 is 12. Is it lesser than 155? Yes. Yes means update the student page count. So it will become 0 plus 12, 12. It becomes 12 and I will allocate 12. So 12 pages he has. Next I moves forward. I will check if 34 can be allocated to him. For that, first I will try adding 34 with the existing page count, which is 12. So I will get 46. Is 46 less than 155? Yes. Yes means I can allocate it. So I will update the student page count. It will become 46. 46 I will allocate. 34 I will allocate. Okay. So 46 pages he has. Next I will move forward. Now before allocating 67, I will see what is 46 plus 67. So 46 plus 67 is 113. Is 113 lesser than 155? Yes. Yes means even this book can be allocated. So I will just allocate that book. So I will get 67. And obviously I will update my student page count, which will become 46 plus 67, which is 113. Any confusion till here? Yes sir, till here you have done. Next what, sir? Next what, you may ask. Next what means, again I am within a loop. I will move forward and I will see if 90 can be allocated. For that, first I will check 90 plus 113 is 203. Is 203 less than 155? No. No means I can't allocate. At the same time, I can't leave this book. Every book should be allocated, which means I will come to else. Else means what? I need a new student. So student plus plus student value will become 2. Now I will check whether that student value is lesser than or greater than this B value, because I can have only maximum 2 students. No, it's not greater, it is equal to, which means still I am correct. So what I will do is, I will bring my new student, and to that new student I am going to allocate this book. So I want to allocate 90. So when I allocate 90, would you agree now this is a new student? His student page count should be updated. So whatever was the previous student page count, I will just assign AR of I to it, which means student page count, which is 113, is now going to become 90. It's now going to become 90, which means this student has 90. Have you allocated all? Because the next time when you loop, I goes for outside and looping stops. So you allocated all the books. So then, if you have been successfully able to allocate all the books, then look at this first student. 12 plus 34 plus 67, 113 book is the maximum value that you have been able to allocate. So now what I am trying to say is that maybe this could be a possible solution. We do not know. This could be a possible solution. So what I will do is, if successfully I have been able to allocate, if this was a possible solution, if the answer is yes or true based on this logic, what I will do is, I will just have a variable called as result, and in that result I will just temporarily store this value 155. Now I may be right, I may be wrong, but think about it. Your duty is to find the minimum of this maximum value, which means yes, 155 is a solution, but there could also be a solution which is lesser than 155. If 155 is a solution, there could be a lesser solution, lesser solution, lesser solution, which means I want my binary search to be restricted to this half. If I want binary search to be restricted to this half and check if there is a solution on this side, should low be adjusted or should high be adjusted? Anyone with eyes will tell me, sir, you have to adjust high as mid minus 1, which means high will become 154. And again repeat the same. Did you understand the core logic of my program? So now that this has become a proper binary search problem, what I would like to do is, I would like to now show a table like this. Low, high, mid. First time low was 12, high was 203, mid was 107. Then you adjusted low as mid plus 1. So 108, 203, you got 155. Then you adjusted high as mid minus 1, 154. Now low is same, 108. So now from here we are starting. This, I am putting a box here. This is the logic. This loop is the logic for my is possible solution function. So whenever I calculate a mid value, I will check if that mid value is a possible solution for this logic. Now, if at all, if the control comes out of this loop, if control comes out of this loop, because you can notice in this loop, this condition, if it satisfies, you will get false. False means not a solution. So if it comes out of the loop, it means it is a solution. So what I will do is I will return true. So if it returns true, this is a possible solution. If it returns false, this is not a solution. This m value is not a solution. I hope you're able to think. This is my variable called as result. Okay. So previously we had the result, we had stored it as 155. This was the value of result. Now let's continue. Okay. Now watch it, guys. This is my binary search algorithm that I'm just showing you here. So what are we doing? Binary search means, as long as low is less than equal to high. Find mid, low plus high divided by 2. Now you found mid, you're assuming that is the maximum pages. So I'm checking, is that a solution? How? By calling this function. So I'll say if in case is possible solution and I'll pass m. It may return false, it may return true. If it returns true, then I'll assume that m value is the answer. So see, m value I'll assign it to result. And if m value is assigned to result, like I just told you, we want to restrict the search to the left side. If you want to restrict the search to the left side, high should become mid minus 1. That is what I am doing. High is equal to mid minus 1. Otherwise, this was not enough number of pages to allocate. So you want to increase it. If you want to increase it, search should be restricted to this side. So low should become mid plus 1. That is what I am showing. Low becomes equal to mid plus 1. This is the core logic of our program. Did everybody understand? Now let's start. Okay. So till here it is over. 108, 154. If I find mid, 108 plus 154 divided by 2 is 131. 131, is it a possible solution? Pass that to is possible solution. In is possible solution, you are running a loop which is I starts from here and it has to go till the end. Okay. So I will see whether 12 can be allocated. Now students count is 1 initially, student page count is 0. So I'll allocate 12 because 0 plus 12 is 12, 12 is less than 131. So definitely I can allocate. So I'll allocate 12. Next what, sir? Next I moves forward. I will check if 34 can be allocated. 12 plus 34 is 46. 46 is less than 131, which means I can allocate 34. And accordingly, my student page count is also increasing. I did not show you every time. Next, what I'm going to do is I'm going to move I forward and then I will get 67. So if 67 I added to the existing 46, I'll get 113. 113 is lesser than 131, which means I can also allocate 67. Did you guys understand? Great, sir, you allocated 67. What else? What else means I moves forward and then I will check whether I can allocate 90 also. When I add 90 to the existing value, this is 113, I will get 203, which is greater than 131, which means I can't allocate. If I can't allocate, I will come to else. In else part, what am I saying? I need one more student, so student plus plus, student value becomes 2. I am checking if the student value has become greater than the number of students which is allowed, which is 2. No, it is equal to, which means now new student, for him I want to allocate 90. So I will allocate 90 to him. How will you show that as code? AR of I, assign it to SPC. SPC was 113, now it will become 90, which means second student has a student page count of 90. Any confusion till here? After that, I moves forward, it goes outside the loop. That's it. Now, so tell me, you will come out of this loop. If you successfully come out of this loop, what are you telling? True. Yes, it is a possible solution. And it is a possible solution because were you not successful in allocating all the books to 2 students? You are successful. But is it the minimum of the maximum? We still don't know, but you got true. If you get true, then that mid value, assume that is the result. So result will be updated. It was 155, now it becomes 131. Any confusion? But now it is 131, but I may have a solution which is lesser than 131. So what I will do is high will become mid minus 1. Low will be the same. Again calculate mid. 108 plus 130 is nothing but 119. Is 119 a possible solution? Pass it to this function. In this function, again we will start from scratch. So this is I value. It is 12. Student count is initially 1. SPC is 0. And this time I am quickly tracing the program. Watch it. So obviously 12 can be allocated because it is lesser than 119. Right, 119, yes, it is lesser than 119. Next, obviously 34 also, 34 also can be allocated because 46 is also lesser than 119. Next, 67 also can it be allocated? Yes, because it is 113. 113 is lesser than 119. Okay, so I value, as you know, is here. Then if I go to 90, obviously 90 cannot be allocated because 203 will become greater than 119, which means student plus plus, student becomes 2. Is it greater than B? No, which means I am correct. Now to the new student I want to allocate 90. I will allocate 90. How are you able to think? So even this is a possible solution because see, I went outside. I went outside means successfully I have allocated all the books to the students. So you will return true. So 119 is also a possible solution. But you don't know. You are within a loop. You could have a solution lesser than that. So what will you do? High, left half you have to select. So high will become mid minus 1. Low remains the same. 108 plus 118 is nothing but 113. Now 113 is my new mid value. Is this a possible solution? Pass it to the function. Function will again start its duty. Starts from scratch. Okay. So I will start. 12 can be allocated. 34 can be allocated because it is still lesser than 113. Now if 67 I allocate, then it is equal to 113, which means even this can be allocated. Then what happens is, next I will check if 90 can be allocated. No, if I add 90 to it, I will get 203, which is a mistake, right? So student plus plus, new student. Yes, it is not greater than B, no problem. So to the new student, I will allocate 90. I goes outside. If I goes outside, then we know that, yes, successfully we have allocated. You will come out of the loop, return true. Oh, even that is a possible solution. That is also a possible solution. So I will update my M value and my M value becomes 113. How are you able to think? Now I am within a loop. There could be something lesser than 113. So again, high becomes mid minus 1. Low is the same. 108 plus 112 divided by 2 is 110. Is 110 a possible solution? I am checking. So I will call is possible solution. Now let us quickly see whether it is possible. So 110, isn't it? Now watch it. 12 can be allocated. Yes, less than 112. Plus 34. 46 is also less than 110. Plus 67 is 113. 113 is not lesser than 110. If it is not lesser than 110, you have to allocate it to the next student. So student plus plus, second student. To the second student, I am going to allocate this 67. Good. Next Next one is 90. Now if I allocate 90 to this, 67 plus 90 is 157. Obviously it is not lesser than 110, which means I need one more student. I'll come to else. I'll do student plus plus. Student becomes 3. Third student I need. Now, is that greater than 2? Yes, because only 2 students are allowed, which means this condition is true. If this condition is true, return false. Not a possible solution. Come to else. If it's not a possible solution, then you must increase the number of pages. So you can't look to your left, you can look to your right. Even now, my result is 113 only. So now watch it. Low becomes mid plus 1. High remains the same. 111 plus 112 is nothing but 111. Is 111 a possible solution? Send it. Again from scratch, we are checking. So 111, okay. So 12, yes, you can allocate less than 111. Plus next one, 34, you can allocate. 46 is 100, less than 111. Plus 67 if I do, then I will get 113. It is not less than 111. Problem, which means I need a new student, student plus plus. Second student, I need 2 students, so this condition will not be true. So to the next student, I am going to allocate 67. Good, I allocated 67. Next 90, I will allocate, so 67 is less than 111, no problem. Plus 90 will become 157. 157 is not greater than 111, which means this is not a possible solution. So what will happen is student plus plus. Student will become 3. 3 is greater than 2, which means you will return false. False means come to else. So see, even now my result is 113 only. It didn't get updated. Now low is equal to mid plus 1. So low becomes 112, mid is 112. 112 divided by 2 is 112. So new mid is 112. Is that a possible solution? Again start from scratch. So 12, yes, can be allocated. Plus 34, 46 is also less than 112, can be allocated. Plus 67, no, is 113, is lesser than 112, is less than 113, which means you can't. If you can't, you need a new student, student plus plus, it becomes 2. 2 is not greater than 2, which means now to the new student AR of I will allocate, which is 67. Now, okay, 67 is less than 112. Next, 90, if I add, it becomes 157. Problem, because it became greater. Greater means you will again increment student, it will become 3. 3 will become greater than 2. This condition will be true. You will return false. False means you will come to else. And then low becomes equal to mid plus 1, 113. High remains the same. Low became greater than high. Binary search condition fails, you will come outside. When you come outside, what is the value of result? 113. That is your solution. 113 is your solution. 113 is the maximum number of pages that can be allocated to a single student, and out of all the different combinations, of maximum pages that you searched for, 113 is the minimum possible solution. Did you understand? So at the outset, you probably didn't realize this could be solved with binary search, but 100% it could have been. It could have been. So I hope you found this logic interesting. Next, let me show you that 99% the logic is done, but there are few conditions which you need to still apply, which you did not think of. What are those? Let me show you. Now guys, what I want you to understand is, assume you had an array like this, right? 205, 72, 36, 85. Now the number of students you have to distribute the books is 2 students. Now I want you to understand, how did our program work? First we will set a low value, which is nothing but the minimum here, so 36. We will set the high value, which is nothing but the sum of all the pages of all the books, which is 398. Now if I find mid, 36 plus 398 divided by 2 is nothing but 199, that is mid. Now I want you to understand something. We want to see if this is a possible solution. To check if this is a possible solution, we will pass it to this isPossible function. Now in this possible function, you will be iterating over this array. There the first element is 205. If you notice, 205 is greater than this. If it is greater than this, will I be able to allocate it to a student? No. Which means I will never be able to allocate this 205 to a student, because I am saying one student at the max should have 199 pages. I hope you are able to think. So would you agree that this is another condition which you must take care of to see whether a given value is a possible solution or not? What is that? the mid value, if it is lesser than any of the elements in my array, then that book can never be allocated. And if that book can never be allocated, there is a problem, because the condition says that you must contiguously allocate. So if 205 I cannot allocate to a student, then I cannot move to the next book, because this book has to be allocated. But I am saying maximum pages is 199, but this is greater than 199. So 199 is not a possible solution. So you have to think of all such cases. So would you agree? In this loop, at the beginning itself, I will attach one more condition. If in case the ith element is greater than the m value, then directly return false, because it's not a solution. So you can notice here clearly that in two conditions, two cases, you will say that m is not a solution. Case number 1, where m value is lesser than the ith element, or ith element is greater than the m value. The second condition, if it's in case the student count becomes greater than b, which is the maximum students that you have with you. I hope you're able to think. So in both the conditions, it's not a possible solution. But if you come out of the loop, it is a possible solution. You will return true. Now that you have understood the logic of the program, it's time for us to go write some code. Let's do it. Now let's write some code. As you can see, I have my array of books. Each value in the array represents the number of pages in the book, and the number of students to whom they must be allocated is 2. I am calling a function called as maxPage, passing my array and the b value. This is my function maxPage, which is returning an integer, and this integer is nothing but the maximum number of pages that a student or one of the student has, and it is also the minimum compared to all the different combinations. Okay, so I will come here. First and foremost, think about this, guys. Assume my array had two values. This is my array. B value is 3, which means he's asking me to allocate 2 books between 3 students. Is it possible? Is it possible? If b value is greater than the number of elements in my array or the size of the array, can allocation be possible? I'll have to tear one book into 2 pieces and give, but one whole book has to be allocated to one student. That is the condition. Which means if such an input is given to you, directly you must tell not possible. So see what I will do. If in case b value is greater than number of elements, so ar.length, then directly I will return -1. -1 means no answer, not possible. Okay. Now let's start. Now we have to apply our binary search on that search range that I told you. So for that we need low and high. Low is supposed to be the minimum element here. High should be the sum of all the pages. That is what I told you. Now see, I'll tell int L, and what I will do is I don't know which is the minimum. Don't tell me first element is the minimum. There is no guarantee that this array will be sorted. If it is unsorted, first element will not be a minimum. So you have to find minimum. You know how to find the minimum in an array. So what I will do is I will assume the first element is my minimum. AR of 0 I will assign to low. Then I will tell high is equal to, and I need the sum of all the elements. Initially I will make it as 0. Okay. Now watch it. Now I need to find low, which is the minimum. I need to find high, which is the sum. Both I will achieve within a single loop. So I will tell for int I equal to 0, I less than ar.length. I plus plus. Next I will come inside this, and what I will do is both sum and minimum I will find at the same time. Now how do you find minimum? Just check if in case AR of I, is it lesser than the assumed minimum, which is L? If it is lesser, then that should be a minimum. So L is equal to AR of I. Simple. Simple. Below that, what I will do is I also want to find sum, isn't it? Or high. So H is equal to old value of H plus AR of I. This is how you find sum. I am just combining both. In this case, you are combining the logic of finding a minimum in an array and sum of an array. Minimum is low and sum is high. Okay. Now once I come out, low and high is set. Now I will write the loop as long as low is less than equal to high. I will come inside that and I will find the mid. So I will tell m is equal to low plus high divided by 2. Now I will scroll on top. Now whatever is this m value, I want to see whether it's a possible solution or not. So what I will do is, if in case, I will call a function called as isPossible solution. And I will pass SOL is enough. Solution, and I will pass m to it. Any confusion? Now, sir, where is this function? We will write it. But if at all this returns true, see I'll tell double equal to true. There is no need for you to write double equal to true, but I'm just for readability. If this returns true, then I'll come inside if. And what I will do is, okay, it is a possible solution, but there may be a solution which is lesser. Lesser means I should search to the left side, which means first thing what I will do is, I'll create a variable called as result. We will declare it outside. I'll just tell int res equal to, and I'll make it as 0 or -1 initially. -1 means, because if at all there is no result, we want -1, so I'm making it as -1. Now what I will do is, I will in result store that m value. I'll assume that is the result. But there could be a lesser result also. So I will adjust the search by telling h is equal to m-1. High I am adjusting. Good. Else means what? That m was not a possible solution. If it was not a possible solution, search should be to the right side. So L is equal to m+1. That's it. I will come outside this while loop, and whatever is there inside result, I will return it, because that is only the max pages. Now the question is, okay, how to write the logic for is possible solution. So I'll just scroll on top, and I'm going to create one static function, static boolean function called as is possible solution. Static boolean is possible solution, and this is going to accept not only the m value, because it needs the array. So first AR I will pass. It needs the array. Second thing that it needs is the b value, the number of students. Next thing it requires is the m value. 3 things. I'll come inside that, and I'll just scroll down. I'll go to the call, and in the call, see, I will now pass, before I pass m, I will pass both AR and b. I'll pass all 3 values. Okay. Now I will scroll on top. Listen to me. Here what I'm going to do is very simple. What was our logic to check if it is a possible solution? First thing is, I want a variable called as students. So int students, and initially I will initialize it as 1. Next, for that student, I want its page count. So int SPC, student page count, I will make it as 0 initially, because initially I have not allocated anything. Now I want to run a loop, right? So this is my array. Now I want to run a loop on this array and see how many pages or how many books I can allocate to a student. So I'll run a loop for, and I'll run a loop on my array AR. Now inside the loop, what are we going to do inside the loop? Very simple. Bring it down. Now inside this loop, what we have to do is simple. First and foremost, you have to allocate to a student, but before allocating, you must check a condition. What is the condition? If in case, whatever is the student page count, to that if I add the ith element in my array, is this lesser than or equal to this m, because that is the maximum number of pages we can allocate. If this condition is true, then I will allocate it to the student. And how will you allocate it to the student? By updating SPC. So SPC is equal to old value of SPC plus AR of I. Now, if in case this condition is false, it means that for that student you can't allocate anymore. So you need one more student. So students plus plus. I'll increase the students count. Now I increase the student count, but what if that student count became greater than b? Because the question told only b students. So you should always check that if in case. And I will tell is students greater than b. If it is greater than b, directly I will tell no, this is not the solution, return false. Return false. But if this is not the case, then I will come down and I will tell, hey, now for the next student, that ith element you allocate. So I will tell SPC is equal to AR of I. So the old value of SPC gets updated with this. Any confusion? So this is the case. Now, if I come out of this loop, it means what? Yes, it is a solution. So return true, I will tell. Now here, as I told you, one more condition you have to check. So I will go back here. What was that condition? I told you that if in case, right, this is the array. Let us assume that 205 example I am bringing. This is that array. Now the element is greater than the mid value. Let us assume m value was some 155. This is 205. So if maximum pages you can allocate is 105 and one book has 205 pages, you can't allocate at all. So if in case, I will tell if AR of I is greater than m, then also that m value is not a solution, so return false. That's pretty much it, my friends. That's pretty much it. Now let's go down to the main method, and if you notice in the main method, I've already called max page and I put it within sysout, so output should come. So for this particular example, the answer should be 113. That is what we traced. So if I execute, one can notice clearly you have got 113, which is the solution, right? So now the bigger question is, what is the time complexity of this solution? Now very simple. Come down. Now here if you notice, first and foremost, this max pages, it is using binary search algorithm, this while loop, right? So first of all, you are finding max and sum. So for this you have to iterate over the entire length of the array. So would you agree that this would take maybe n would be the time complexity of this loop, because you have to go through the entire loop. Next I will come here. Here what is going to happen is you are going to have log n, but it's not n, because see, whenever you use binary search, half it will be going, so size of input will keep reducing. So it is logarithmic. So I'll just tell plus log of, don't tell n, because you are not iterating over the array. You are not iterating over the array. You are iterating over the search range. What is the search range? Low value, forget about low value, high value. What is the high value? Sum of all the elements. So from the low you have to go till the sum of all the elements. So that is the size of your input. Size of your input is not n, it is low till high. High is what? Sum of all the elements, sum of all the elements. So would you agree? I can say sum of my array A. In this case we have called it as AR, but question says A, so I am calling it as A. Next, you are calling is possible solution. Go to is possible solution. If I go to is possible solution, look at the loop. It's going from 0 till the length of the array. So if there are n elements, n is the time complexity. So plus n, which means it becomes 2n plus log of A. But I have also told you that this plus is not what we use usually. So we would use it as multiplication sign, which means you can say this is 2n log of, sorry, this is sum of A, not just A, sum of A. Constants are ignored, which means it is big O of n log of sum of A. In other words, somewhere logarithmic you have got. So this is the time complexity. Any confusion till this point of time? So I hope you enjoyed this Google question, and I hope how to think of different scenarios, break down a question and approach it is becoming clearer and clearer. More such questions which initially may not seem like binary search but are actually binary search based solutions we will discuss in the future. But I sincerely hope you guys are enjoying these classes and most importantly are practicing. I'll catch you in the next video. Till then, take care of yourselves. Bye bye.